Hello and welcome back to tonight's storytelling journey. Tonight we will travel back in time, more than 252 million years, to an Earth very different from the world we know today. Back then, dinosaurs had not yet appeared. The continents were still joined together into the vast supercontinent of Pangaea. The ocean surrounded the planet like an ancient mirror, while on land, strange creatures moved beneath the hot, dry sky of the Permian period. But within that world which seemed so enduring, something had begun to change. Before we begin, leave a gentle comment below. Where are you listening from? A city glowing with lights, a quiet room, a countryside, already wrapped in darkness, or somewhere far away on the other side of the world? And what time is it where you are right now? Lie down comfortably and join me as we step into the story of the Permian Extinction, the catastrophe that once caused nearly all life on Earth to disappear. Imagine opening your eyes on a morning from an unimaginably distant past, farther back than every city, every kingdom, every human footprint ever left upon the Earth. There is no sound of vehicles, no glow of lights, no rooftops, no roads. There is only an ancient planet breathing beneath a vast sky where time moves so slowly that even a mountain might seem like a living thing still growing. This is Earth during the Permian period, more than 252 million years ago. It is a world before the age of dinosaurs, before birds, before flowers, blooming across grasslands, even before the first calls of mammals in the night. If you were standing there, you would not see the familiar blue planet we know today. You would see another Earth, drier, wider, quieter, and so strange that it might feel as though you had stepped into a dream made of stone and dust. Beneath your feet, there is no small continent surrounded by the sea. At this time, most of the land on Earth has gathered into one enormous mass, a supercontinent so vast it is difficult to imagine, known as Pangaea. It stretches across many climate zones, from the hot regions near the equator to more distant lands where the seasons shift more sharply. If you could rise very high into the sky and look down, you would see the land like a gigantic body lying in the middle of a boundless ocean. Surrounding Pangaea is the immense Pangaea Ocean, which almost embraces the rest of the planet. To the east of that supercontinent lies the ancient Tethys Sea, where shallow, warm, sunlit waters could nourish many strange marine creatures. But deep within the interior of Pangaea, far from the coastline, moisture carried by the wind has difficulty reaching the land. The ground becomes drier. In many places there are wide open spaces, semi-desert regions, old riverbeds, and cracked stretches of earth beneath the sun. You walk slowly across pale red ground, where fine dust clings to your feet like the memory of a young planet. The air feels heavy and dry. Wind moves over the land, carrying the scent of minerals, ancient vegetation, and mud baked hard beneath the sunlight. Far away, low clouds drift slowly, but they do not always bring rain. Deep in the heart of the supercontinent, the weather can be harsh. The dry season can last a long time, and when the rainy season comes, it may turn quiet channels into muddy, rushing streams. The Permian world is not the world of soft green forests that we often imagine when thinking of prehistory. There are forests, but they are not like modern forests. In some wetter regions, you may find ancient seed plants, ferns, low, woody vegetation, and groups of plants already accustomed to drier climates. The leaves, the trunks, the seeds all belong to a kind of nature far older than the flower-filled forests that would appear much later. If you stand beneath the shade of a cluster of ancient trees, you will hear a very different kind of sound. There is no bird song because birds have not yet appeared, There is no humming of bees around flowers because modern flowers have not yet spread across the earth. The silence here is deeper, emptier, as if the world is still learning how to create its own music. Now and then there is the sound of ancient insects slipping through dry vegetation, small feet moving across the ground, or some creature crawling through stiff leaves. By the Permian period, insects had already been present for a very long time. Some groups of insects glide through the light, but the sky is not yet as crowded as it would become in later worlds. They do not fly around brilliant gardens of flowers, but move among ferns, seed plants, and damp patches of land. Their thin wings catch the ancient sunlight for a brief moment, then vanish into the shade. If you listen closely, you can feel that life is not loud here, but it is present everywhere, small, persistent, and quiet. On the ground, larger footprints begin to appear. This is the world of creatures that are no longer entirely like ancient amphibians, but are not yet modern reptiles in the way we understand them today. Many species belong to the synapsids, a group of immense importance in the history of evolution, now occupying major roles on land. They are not dinosaurs. They belong to another lineage very distant yet from that synapsid line. Through countless later transformations, mammals will eventually emerge. One of the most famous images of the Permian period is Dimetrodon, the sail-backed creature, often mistaken for a dinosaur, even though it lived long before dinosaurs appeared. Imagine a low body, 4 strong, heavy limbs, a large head, sharp teeth, and rising from its back, a tall sail like a fan of bone and skin. It walks slowly across the dry land, leaving footprints in hardened mud. Each step is unhurried, but carries the quiet power of an ancient predator accustomed to sun and dust. The sail on Dimetrodon's back remains a detail that continues to fascinate us. Scientists have suggested many possibilities, from temperature regulation to display recognition or attracting mates. Although its exact primary function is still discussed, that image has become a symbol of the world before dinosaurs. In the slanting light of afternoon over Pangaea, the sail may appear like a strange shadow, silently cutting across the red ground. But Dimetrodon is not the only inhabitant of the Permian world. In many other regions, groups of therapsids are beginning to diversify. Some have sturdy bodies, strong postures, developed jaws, and skeletal structures that suggest long transitions in the history of life. There are meat eaters, plant eaters, and smaller species that live quietly among shrubs or in shallow burrows. This world is not simply the stage of a few giant monsters. It is a layered ecological network. Among them are the dicynodonts, plant-eating creatures with low, strong bodies, sometimes bearing a beak-like mouth and 2 distinctive tusks. Imagine them moving in small groups across dry land, lowering their heads to search for roots, softer stems, or patches of vegetation left after the heat of the season. They are not beautiful in a modern sense, but they possess a very ancient patience, like rounded shadows moving through the planet's afternoon. Somewhere farther away in other ecological regions, large predators of the late Permian, such as Gorgonopsians, may appear in our imagination as fearsome hunters before the age of dinosaurs. They have powerful skulls, long canine teeth, sturdy bodies, and an appearance that strangely blends reptile-like and mammal-like qualities. If a creature like this passes by, smaller animals fall silent. The bushes stop trembling. The ground itself seems to hold its breath for a few seconds. But what matters in this first chapter is that we do not look at the Permian world as a place filled only with danger. We see it as a world living according to its own order. A predator passing through is not meant to turn the story into something horrifying, but to remind us that every ecosystem has its rhythm. Some creatures search for food, some avoid being eaten. Some dig burrows, some lay eggs. Some follow the scent of water in the air. Together, they create a vast map of life across Pangaea. If you leave the land and move toward the coast, the world changes color. The air may become more humid, the wind carries the taste of salt, and before you shallow waters shine beneath the ancient sun. The Permian Ocean contains creatures very different from those in the oceans of today. Modern corals have not yet come to dominate, as they will later. Bony fish are already present. Ancient sharks glide through deeper waters, and on the seafloor lies a world of brachiopods, crinoids, sponges, ammonoids, and many other groups of invertebrates. Bend down and look through the clear water. You will see hard shells scattered across the sea floor. Creatures that look like flowers, but are actually animals, such as crinoids, extend their soft arms into the current to filter food from the water. Brachiopods cling to rocks or rest on the bottom, opening their shells to let water pass through. Ammonoids, distant relatives of modern squid and octopuses, carry coiled shells and drift or swim through the ocean like living spirals. In some corner of the Permian Sea, trilobites still exist, though their age of glory has long passed. They are very ancient inhabitants of the ocean, having appeared hundreds of millions of years earlier. Their segmented bodies, hard shells, and slow crawling movement are like living memories of times even more remote. If you see a trilobite moving across the sea floor, you are looking at a creature carrying a history longer than almost any life on Earth at that time. The Permian Sea is not only a peaceful place, it also has predators, competition, larger creatures swallowing smaller ones, currents carrying food, faraway storms, shallow waters, and deep waters. Yet compared with the dry breadth of the land, the sea creates a different feeling, softer, more fluid, like a blue cloth breathing around the edge of the supercontinent. There, life builds complex communities layer upon layer, each small shell adding itself to the seafloor. If we walk along the coast as evening falls, the light begins to turn golden. Gentle waves touch low rocks. Far away, the marine creatures do not know they are living in an age that future scientists will one day read through fossils. They simply live as all living beings do in their own present. A shell opens. A fish glides past. A small creature hides in the sand. There is no idea of past or future, only the calm, repeating rhythm of day and night. On Pangaea, as night slowly descends, the temperature in some places may drop quickly. There is no artificial light in the sky, so the darkness here is very deep. The stars appear more clearly than any city dweller in the modern world has ever seen. The Milky Way stretches across the night, unnamed by anyone, untouched by myth or story, yet still there silently shining down upon a planet filled with ancient life. In that darkness, the daytime creatures seek shelter. Smaller animals may begin to move as the light fades. There is a light scratching on the ground, the sound of dry leaves being pushed aside, the movement of a low body slipping through the space between ancient trunks. There is no hoot of an owl, no howl of a wolf, none of the familiar sounds of the modern night. The Permian night has its own music, sparse or stranger, but not empty. What makes this world special is that it stands at a very important place in the history of life. Behind it lie hundreds of millions of years of ancient oceans, coal forests, large amphibians, giant insects, and the slow evolution of life on land. Ahead of it, though, the Permian creatures cannot know. It waits an entirely different age. But at this moment, if you simply stand in the night and look around, you will not see a world about to change. You will see only an ancient earth moving according to its own rhythm. And perhaps that is what makes this first chapter so important. Before an ecosystem disappears, it was once a home. Before fossils became evidence in human hands, they were warm bodies that moved, ate, slept, avoided the sun, searched for water, reproduced, and survived through long days beneath the Permian sky. Every bone lying in stone today once belonged to a real living being in a real world. As you continue walking across Pangaea, you can feel the almost endless breadth of this supercontinent. There are places where the wind travels for a very long time without meeting the sea. There are dry lands where only well-adapted species can endure. There are valleys where water gathers by season, drawing animals from many directions. There are pale blue coastlines where marine creatures open their shells beneath the light. There are sparse forests where tree shadows stretch like ink across ancient ground. All of this creates a world, unlike any age that will come after it. It is not the age of dinosaurs. It is not the age of mammoths. It is not the age of humans. It is its own chapter in the very long book of Earth, a chapter with its own characters, landscapes, and rules. And if we want to understand the Permian extinction, we must begin here with the living quiet and unfamiliar beauty of the world before everything began to change. Because a catastrophe, no matter how vast, only truly matters when we understand what once existed before it. Tonight we have not yet stepped into the great upheaval. We are only standing at its threshold in an afternoon from a very distant past, when Pangaea still stretched beneath the sun, when the ocean still washed against ancient stone shores, when sail-backed creatures, fang-bearing hunters, spiral-shelled beings, and low-bodied animals still moved through their world as if tomorrow would be the same as today. And in that moment, Permian Earth appears not as a number in a science book, but as a place that once had breath shade, footsteps the sound of water, and life spreading across the land and beneath the deep sea. An ancient world vast and fragile, a world we need to look at closely before we begin to hear the first signs of instability rising in the next chapter. You are still standing on the supercontinent of Pangaea. Before you stretch wide lands, sparse bands of trees, old riverbeds winding across red earth, and the low shadows of creatures moving through the light. At first glance, this world still seems to be living as usual. The sun still rises, the wind still blows, plant-eating creatures still lower their heads in search of food, predators still follow tracks through dust and sand. But if you remain there long enough, not for a single day, but through many seasons, many years, many generations, you will begin to realize that the planet's breathing is no longer as steady as before. The dry seasons seem to last longer. Lands that once held seasonal water now remain cracked beneath the sun for longer stretches of time. The riverbeds are still there, but the water runs weaker, or only returns during short, violent rains. Old streaks of mud harden, preserving the footprints of Permian creatures, like lines of writing no one can read. Across the ground, fine dust rises whenever a small herd passes, then slowly settles again like a thin veil falling over the world. Deep within the interior of Pangaea, where the sea lies far away, the climate has always been somewhat harsh. But now that harshness seems to be stretched tighter little by little. The hot days grow longer, rain arrives more unpredictably. The trees do not vanish at once, but in certain places they begin to thin. Patches of green retreat around rivers, around lowlands, around the few places that can still hold a trace of moisture. If you pass through a lowland in the morning, you may see a group of dicynodonts searching for food. They are not in a hurry. They lower their heads using their hard beaks to scrape at the vegetation close to the ground. A few young ones walk near the larger adults. In the Permian world, such a scene was once a familiar part of life on land. But today, the ground is less soft. The low stems are tougher. Young patches of vegetation grow more slowly. The animals must travel farther between places where food can still be found. Each step carries no panic, yet there is a quiet weariness in the movement of the entire group. The first signs of instability often do not arrive as an obvious disaster. They arrive as a greater distance between two places where water can be found. They arrive as a more difficult breeding season. They arrive as weaker young. They arrive as a familiar land becoming less generous than it used to be. At the edge of a sparse forest, the ancient trunks still stand silent beneath the sun. But if you look closely, you will see that the ground beneath them is no longer as thick with small life as before. A few insects still crawl across dry leaves. A few small creatures still slip into the shade. But gaps are beginning to open. Not gaps large enough for anyone to recognize immediately, but subtle spaces like a piece of music beginning to lose a few very small notes. In the fossil record, future, scientists will not see this feeling the way you are sensing it now. They will see it in stone, in layers of sediment stacked one upon another, in changes in ancient pollen traces of plants, shells of marine creatures, animal bones, and communities of life that were once rich, then gradually became poorer. Stone does not tell stories in words, but it preserves the changes that life endured. One layer of rock may say that this place was once shallow water. Another layer may show that the environment had become drier. Another still may preserve traces of creatures that were once common and then appeared less and less. And it is within these details, seemingly silent, that the story of instability begins to emerge. Let us leave the interior of Pangaea and move slowly toward the coast. The journey may take a very long time because this supercontinent is so vast that many regions lie farther from the ocean than almost any place on modern Earth. When you finally hear the sound of waves, the air changes. The wind carries the taste of salt. The ground becomes more humid. Shallow waters stretch out before you, glittering beneath the ancient light. In the previous chapter, the Permian Ocean appeared as a rich world filled with brachiopods, crinoids, ammonoids, ancient fish sponges, and many other invertebrates. But now, if you stand on that same coast across many generations, you will begin to realize that the sea is changing too. Water still washes against the shore. Waves still rise and fall. Yet some shallow waters seem more stagnant during hot days. The current no longer brings the same sense of freshness as before. In enclosed bays, where water exchanges slowly with the open sea, the seafloor may become heavier, darker, and poorer in life. Creatures that live attached to the seabed cannot leave quickly. They can only endure, adapt, or slowly disappear. A small shell opens beneath the current. A filter-feeding creature waits for the water to bring nutrients. An ammonoid drifts through a patch of light and then vanishes into the deep blue-green water. Everything is still happening. Yet behind that appearance of normal life, there is a slow change that no single creature can fully understand. No species knows that its world is entering an increasingly fragile phase. They have no language with which to call it a crisis. They simply live within conditions that are becoming harder and harder to predict. On land, predators also sense the change in their own way, not through thought, but through scent, through footprints, through the absence of prey. A Permian predator moves across the dry land in the slanting light of late afternoon. Its body is low and solid. Its head hangs close to the ground. It stops beside an old footprint, sniffing the dust that is gathered along the edge of the hollow. The track is no longer fresh. The prey passed through long ago. The hot wind has erased much of the scent. It lifts its head, looks toward an area where the vegetation is thinner than before, and continues walking. In a stable ecosystem, predator and prey exist together in a delicate balance. But when the environment changes, that balance does not need to break all at once. It may simply tilt little by little. A herd of plant eaters must travel farther to find food. A weaker young animal is left behind. A predator must spend more energy on every search. A dry season reduces the number of young that survive. A vanished water source forces many species to gather in the same place, making competition more intense. These things may seem small, but in nature, many small things can gather into a great pressure. You can imagine Pangaea as a vast skin stretched across the planet. Upon that skin, life spreads out in many layers: sparse forests, river systems, dry plains, coastlines, shallow waters, and seafloors. Each layer depends on the others in quiet ways. Plants need water and a suitable climate. Plant-eating animals need plants. Predators need prey. Marine creatures need currents, oxygen temperature, and tiny food drifting through the water. When one layer begins to weaken, the others do not collapse immediately, but they begin to tremble. Perhaps in some distant land, a small forest no longer recovers after the dry season. Perhaps on another coast, a community of seafloor creatures gradually declines through many sediment layers. Perhaps in an ancient riverbed, the footprints of a once common species become fewer. Perhaps some species still flourish, while others weaken, causing the ecological picture to become more uneven. From a great distance, the Permian extinction is often told through enormous numbers. But if we step inside the story, it begins with small things like these: a shell missing from a layer of rock, a land that is a little less green, a dry season that lingers, a coastline that remains too still for too long, a community of life losing the diversity it once had. These signs do not appear everywhere at the same time. Earth is not a small room where every candle goes out in a single moment. It is a vast planet with many different environments and many different ecological rhythms. Some places remain relatively stable, while others are already under greater stress. Some groups of organisms decline more quickly. Others endure longer. Some land environments change with the seasons, while the sea records another kind of disturbance. That is why when scientists look back at the end Permian boundary in the geological record, they do not search for only one single mark. They look for a chain of signals: changes in the chemistry of rocks, the disappearance or decline of fossil groups, signs of climate disturbance, traces of marine environments that were no longer as favorable as before. All of it resembles scattered pieces of a very distant night, when the planet began to lose its familiar state of balance. And here in our story, you are still walking among those signs without yet knowing their deeper cause. You pass through a land where the trees have grown thinner. You stop beside a shallow, fading stream. You see footprints overlapping around a small patch of mud where many species have come together. You hear the wind moving through dry trunks, not strong, but persistent. You look up at the sky and see that it is still pale blue, still wide, still seemingly peaceful. But that peace is like still water before a great seasonal change passes through. There is no warning voice. There is no sign clear enough for a Permian creature to understand everything that is coming. There are only small changes silently gathering together. Afternoon descends slowly over Pangaea. Light leans across the ground, stretching the shadows of ancient trees. A herd of plant eaters moves toward a lower region where they hope water may still be found. Farther away, a predator pauses on a rise, its body etched as a dark line against the last light of the day. Beneath the shoreline seafloor, creatures still open their shells, still filter water, still live within the rhythm of the ocean. Looking at that scene, you can still see that the Permian world has not yet been completely transformed. It still appears to be a world in motion, a world that functions. But deep within its climate, its water, its soil, its food chains, and its living communities, the first cracks have already begun to form. This is what makes the first signs of instability so memorable. They are not loud. They do not appear as an immediate disaster. They simply make the world a little harder to live in and then a little harder still. Some species may adapt, some may move, some may endure through many generations. But no ecosystem can withstand pressure forever if the foundation beneath it continues to change. And at the end of the Permian period, that foundation is beginning to shift in a way that life on Earth has never before faced on such a vast scale. When night falls, darkness covers the supercontinent. The star-filled sky is still as bright as it was in the previous chapter. The Milky Way still lies silent across the ancient night. The Permian creatures still seek shelter, still settle down in shallow burrows beneath shrubs beside water or on the soft seafloor. Each species still continues within its own story. But beneath that quiet appearance, the planet has already begun to change. And in the next chapter, we will travel toward the place where those changes become far more intense, where the ancient northern ground begins to open, and one of the greatest geological events in Earth's history silently enters the story. Imagine you are standing on a vast stretch of land in a place that today belongs to Siberia. But this is not the frozen Siberia we know from modern maps. This is Siberia from more than 252 million years ago, in another world, on another supercontinent, beneath another atmosphere. There are no snow forests, there are no humans, there are no hunters' footprints, no sound of wheels on ice. There is only ancient ground stretching outward, silent and heavy, as if it is holding a secret buried very deep below. At first, everything may still seem quiet. Wind glides across open ground. Dust curls low, then fades into the pale light. A few creatures pass along the far edge of Pangaea, searching for water, searching for shade, searching for the familiar paths their ancestors had followed for many generations. If you stood there for only one morning, you might not notice anything especially strange. The world is still wide, the sun still rises, the ground still lies beneath your feet like something solid and enduring. But deep beneath the stone, the planet is shifting. In places, the naked eye cannot see, magma begins to rise from inside the earth. It is not a small stream of fire, not a lonely volcano with a clear crater at its peak. What is forming here is far larger, far slower, and far more frightening. It is an immense magmatic system, spreading beneath Earth's crust, pressing into cracks, slipping through ancient layers of rock, heating sedimentary beds that have lain still for a length of time, almost impossible to imagine. Imagine placing your hand upon the ground. You would not feel it burning at once. But perhaps if you stood long enough inside this story, you would sense a very faint tension, as though the crust beneath your feet were no longer completely asleep, as though an entire land were holding its breath before opening. Then the first fractures appear, not like a small crack in the floor of a house, but long wounds across the skin of the planet, where rock is stretched, compressed, and torn apart by forces rising from far below. From those fissures, lava can spill out, not building the familiar cone-shaped volcano we often see in pictures, but spreading outward in dark, basaltic flows, moving across the surface like burning carpets. The lava does not need to be fast to become terrifying. It only needs to keep going. It pours across lowlands, fills, cracks, covers older layers of rock, and slowly cools into broad, black steps of stone. Then another flow comes, then another after that. Over time, layers of lava pile upon one another, like pages of fire written by the depths of the earth. Much later, this stepped landscape would be part of why people called this place the Traps, from a word closely associated with stair-like formations in geology. But in that ancient moment, no one gives it a name. There is no geologist standing there to take notes. There is no map marking the eruption zone. There is only Earth opening a violent chapter in its own history. If you stand very far away, you may see the horizon change color. A deep red glow stretches through the air. It is not like sunset because it does not soften when the sun goes down. It smolders from the ground. Smoke and heat rise upward, bending the shapes of distant hills. The air trembles slightly, as if the whole sky is being heated through an invisible pane of glass. The smell of the world changes as well. In our imagination, it might be the sharp odor of sulfur, the smell of hot rock, dry smoke, and layers of earth being heated after millions of years of silence. The gases rising into the sky are not only the smoke visible to the eye. Many of the most dangerous things are invisible. Carbon dioxide, methane, sulfur dioxide. Other volatile substances may escape from magma, from heated rock, from sedimentary layers rich in material that magma has invaded. This is what makes the Siberian Traps more than a volcanic spectacle. It is a geological machine. The lava on the surface is only the most visible part. Deep below magma can also spread sideways as intrusive bodies of rock, like enormous tongues of fire, entering sedimentary layers. When hot magma comes into contact with carbon-rich rock coal salts or reactive sediments, it can heat them and release additional gases. In this way, what enters the atmosphere does not come only from eruptive vents, but from an entire region of Earth's crust being heated from within. Imagine a gigantic kitchen beneath the planet. There is no small flame on a stove. There is no simple pot of boiling water. Instead, there are thousands, even tens of thousands, of magmatic cracks silently threading through stone, heating ancient sediments, releasing gases, and driving volatile substances upward into the sky. Each place is only one part of the system. But when all of them are added together, they create a disturbance large enough to force the global atmosphere to change. On the ground near the eruption zone, life certainly no longer feels normal. A small creature runs across warm dust. It does not understand what is happening. It only knows that the ground ahead is hotter. The air is more unpleasant. Places that once offered shelter are now covered by ash dust or new rock. A lava flow far away may not catch it, but the familiar landscape is changing. A stream may be blocked. Plants may be buried. Old paths vanish beneath dark stone. Larger creatures do not understand the scale of the disturbance either. They know nothing of carbon climate or geological cycles. They live only by instinct. If there is smoke, they avoid it. If the ground is too hot, they take another route. If water is affected, they search for a new place. If food becomes scarce, they move farther. But once change spreads across many seasons, many regions, and many generations, instinct alone is no longer enough to keep the world as it once was. For a creature that lives only a few years or a few decades, the world is simply becoming stranger with every season. For a geologist looking back hundreds of millions of years later, it is an enormous chapter of upheaval in Earth's history. And between these two ways of seeing the story becomes both intimate and overwhelming. You can picture an afternoon on the edge of the affected region. The sky is not completely dark, but the light has grown duller. The sun resembles a blurred spot behind a veil of gas and dust. Wind moves across the open land, carrying fine particles from somewhere far away. A plant-eating animal pauses, lifts its head, breathes in the air, then slowly turns in another direction. It does not know that in the sky above, Invisible gases are beginning to change the way the planet holds heat. Greenhouse gases do not kill life like a claw descending from the heavens. They work more quietly. They trap more heat. They make hot seasons more severe. They make already dry regions even harsher. They cause the climate system already complex to begin drifting away from the conditions to which many Permian creatures had adapted. And because Pangaea is an immense supercontinent, changes in heat and moisture can make the interior even more difficult to endure. One hot day does not create a mass extinction. One dry season does not wipe out a world. But when hot days pile one upon another, when dry seasons grow longer, when the atmosphere receives enormous amounts of gas over time, the planet begins to enter a dangerous path. The greatest catastrophes do not always need to appear like monsters. Sometimes they only need to make every condition for life a little worse, and then a little worse again until many creatures can no longer adapt in time. The Siberian traps, then, are like the burning heart of the late Permian upheaval. They are not the entire story, but they are one of the most important forces that turn the story in a new direction. From quiet signs of instability, we begin to see a deeper mechanism. It is not simply that the land becomes dry by chance. It is not simply that the sea changes because of an unusual season. Beneath it all, the interior of the earth is pumping new elements into the atmosphere and environment, causing the entire Earth system to sway. In places where lava has passed, the landscape afterward becomes almost unrecognizable. A land that once held vegetation, small streams, and the footprints of living creatures can be covered by black basalt. When lava cools, it hardens into a rough, dark surface, hot by day and cold again at night. Over time, new sheets of lava cover older ones, building a stair-stepped world of stone. Not every place on Earth sees the fire. A creature living very far from Siberia may never see lava at all. It may live beside a coast in a sparse forest or on a dry plain far from the eruption zone. But the frightening thing about atmospheric disturbance is that distance does not protect everything. Gases enter the sky. Winds carry particles and volatile substances far away. Heat is retained within the global system. What begins in a northern land can spread without footsteps, without claws, without the shadow of a predator. This is the moment when the story of Permian Earth becomes larger than any single survival tale. A dicynodont may find a new waterhole. A predator may change direction. A plant species may grow better in one of the remaining moist regions. But when climate, land, water, and air are all changing together, each small solution begins to lose its power. Life is deeply resilient, but that resilience still needs a foundation. It needs temperatures that do not exceed certain limits. It needs water that remains stable enough. It needs food chains that do not break too quickly. It needs oceans and an atmosphere that still preserve the conditions living bodies can endure. The Siberian traps begin to shake that foundation. In the smoke and dust of the ancient north, the sky may change color again and again. There are days when the light is filtered through a hazy layer of gas. There are deep red afternoons that linger, not only because the sun is setting, but because the air is filled with particles and heat. There are rains with a stranger taste, touching rock and soil, like drops of water falling from a sky being altered by the earth's own depths. But in our telling, let everything remain slow. There is no need to turn the Siberian traps into a scene of endless chaos. What makes them frightening is their scale and their persistence. Fire may flare in one place and then cool, but the consequences of escaping gases accumulating heat and a disturbed carbon cycle can continue moving through the planet long after a lava flow has turned to stone. A crack in the ground may close with cooled rock, but the atmosphere has received something it cannot quickly return to its former state. Seen through the eyes of a storyteller, Earth itself may appear like an ancient body. In the previous chapter, that body had begun to breathe unevenly. In this chapter, deep within that body, a fever begins to rise. Not the fever of a single day, not the fever that can fade after a night's sleep. It is a fever of hot stone, greenhouse gases, magma, and geological time. A fever that plants marine creatures, land animals, and fragile ecosystems will feel in very different ways. You stand on a distant rise, looking toward the northern horizon. A faint red light is still there, like an ember glowing beneath the edge of the sky. Beneath your feet, the ground is quieter than it appears. Far away, a herd of ancient creatures continues moving in silence. They do not know that behind that sky, one of the largest geological events in the history of the planet is entering a phase that will change everything. No voice rises over Pangaea to say that the climate is about to become different, that the oceans will be placed under immense pressure, that food chains will be tested to their limits. The creatures only sense that today is a little hotter, that water is a little farther away, that the sky is a little dimmer, that the wind carries a slightly stranger smell. But for Earth, all those little things are adding up. In the land of the Siberian traps, the depths of the earth have awakened. They awaken not like a mythical beast rising from darkness, but like an immense geological system, slow and coldly indifferent. It has no intention. It is not angry. It does not punish. It simply follows the deep laws of the planet. Hot rock rises, Earth's crust splits open, magma spreads gases, escape into the sky, and the living environment begins to change. That is why the Permian catastrophe does not need a villain. It does not need an invisible hand. It does not need a mythical moment. It only needs a planet changing itself too quickly for most life to endure. When night falls over the ancient northern land, lava still glows in some places beneath the darkness. Slow red-orange streams creep across the ground like rivers without water. Above them, the star-filled sky is partly hidden by smoke and haze. The air is not entirely silent. There is the sound of cracking stone. There is the sound of gas escaping. There is the low, distant sound of fire. There is the sound of wind passing through a landscape, being rewritten by heat. You stand there very small before an earth far too large, and in that moment you understand that the story has crossed into a new threshold. The Permian world is no longer facing only scattered signs of instability. Now a colossal source of disturbance has emerged from within the planet itself. What happens at the Siberian traps will not remain in Siberia. It will enter the air. It will touch the climate. It will gradually reach the land, the coasts, and the oceans. But the ocean will be where we feel those consequences most deeply, for beneath that seemingly peaceful water, another change is waiting. The water will grow warmer. Oxygen will become more precious. The creatures that once lived in the Permian seas will enter a trial they cannot see, cannot flee, and cannot name. After the ancient northern depths of the earth began to awaken, our story leaves behind the smoldering flows of lava, leaves behind the sky blurred by gas and ash, and descends into a place that seems at first far more peaceful. The ocean. If you were standing on a Permian shoreline in the morning, you might not yet see anything too frightening. Waves still touch the rocks gently. The wind still carries the taste of salt across the land. Sunlight still spreads across the water in long gleaming streaks, shimmering like a blue cloth, slowly moving in the light. From the outside, the sea still looks vast, still deep, still seemingly stronger than every disturbance on land. But the ocean too can grow weary. It has no voice like a human being. It cannot cry out when it is changed. It only records instability in temperature, in currents, in dissolved oxygen, in the color of the water, in layers of mud settling onto the seafloor, and in the gradual absence of creatures that once lived densely beneath the ancient waters. Imagine you are stepping into a shallow sea at the edge of Pangaea. At first, the water is clear and warm, wrapping around your feet like a soft breath. Beneath you is a seafloor of sand, mud hardshell fragments, small creatures clinging to rocks, and quiet bodies filtering food from the current. This was once a rich world. It was not like a modern coral reef, nor like the ocean filled with brilliant fish that we often see in documentaries today, but it was still a world alive in its own Permian way. On the seafloor, brachiopods open their two shells and let water pass through their bodies. Crinoids, creatures that look like flowers but are actually animals, stretch their soft arms into the current to catch tiny food particles drifting by. Ammonoids with their spiral shells move quietly through the open water. Farther away, ancient fish and marine predators slip through deeper layers where the light grows weaker and the blue turns into darkness. Everything seems to be working, but then the water begins to grow warmer. This change is not always easy to notice in a single day. An ammonoid cannot compare the temperature of today with the temperature from 1,000 years earlier. A brachiopod attached to the seafloor cannot know that the entire planet is entering a dangerous phase of warming. It only senses the environment around it through very simple limits, whether the water is still suitable for life, whether the current still brings food, whether its body can still exchange with the world outside. When seawater warms, it holds less dissolved oxygen. This matters deeply. In the ocean, oxygen is not something visible to the eye. It has no color. It has no shape. But for marine creatures, oxygen is the boundary between an environment that can sustain life and one that becomes increasingly difficult to endure. At the same time, as the temperature rises, many organisms need more energy to keep their bodies alive. Their bodies function in warmer water, their metabolism shifts, and their demand for oxygen increases. And so the ocean creates a harsh paradox. The water holds less oxygen, while the creatures living within it need more. Look at a small creature lying on the seafloor. It does not run, it does not cry out. It simply opens its shell filters, water, and tries to continue living as its ancestors had lived for millions of years. But the water passing through its body is no longer the same. There is less oxygen. The temperature is higher. For a few days, it may still endure. For a few seasons, perhaps it may still survive. But across many generations, the entire community around it begins to change. Some sensitive species disappear first. Some more tolerant species remain longer. A seafloor that once held many different forms of life gradually becomes simpler. In stagnant, shallow waters, the problem becomes even clearer. When water exchanges poorly with the open sea, oxygen can drop sharply near the bottom. Dark layers of mud begin to accumulate. Creatures that need more oxygen can no longer live there easily. A seafloor once covered with small bodies clinging to rocks now becomes thinner, quieter, and less full of movement. You swim slowly through that water in your imagination. Sunlight still filters down from above, but it no longer carries the same clear feeling as before. Tiny particles drift through the water. In some places, the seafloor appears darker. There are empty spaces where in an earlier time there should have been many creatures, clinging, crawling, filtering food, or hiding. The silence underwater is not like the silence on land. It is thicker, heavier, as though the whole sea is holding a sorrowful secret. In a healthy ocean, layers of water constantly exchange with one another. Wind temperature, salinity, and currents help bring oxygen from the surface down into deeper waters, while also carrying nutrients through many different regions. But when the climate changes sharply, when the water grows warmer, when layers of water become harder to mix, the deeper and more stagnant parts of the ocean can fall into a state of low oxygen. And when oxygen runs out, the ocean does not merely become harder to live in, it can also become more chemically unfamiliar. In some severely oxygen-poor environments, microbial processes can create conditions that are more toxic to many complex forms of life. Scientists use words like anoxia to describe oxygen deficiency and euxinia to describe oxygen-poor waters associated with hydrogen sulfide. To an ordinary listener, those words may sound dry and technical. But if we turn them into an image, we can understand it simply like this. A part of the ocean is no longer an easy-breathing home for marine life. It becomes a heavy, dark, oxygen-poor body of water where many species can no longer continue living as before. Imagine a sea where crinoids once stretched themselves like ancient flowers. The current flowed through them, bringing food and oxygen. But then the current weakened. The seafloor became poorer in oxygen. Some individuals could no longer hold on. Their soft arms no longer opened in the water. Pieces of their stems slowly broke apart, mixing with mud and old shells. Over a very long time, what was once a living community became a layer of traces lying silent in stone. Elsewhere, ammonoids still move quietly through open water. They are more flexible than many creatures fixed to the sea floor, able to seek out different water layers, follow more suitable temperatures, or move after the food that remains. But when the change does not happen only in one small bay and instead spreads across wide regions of the sea, even the ability to move is no longer a certain escape. The sea is too vast for a single creature to understand completely, yet too connected for a great disturbance to remain in only one place. Creatures already accustomed to warm, low-oxygen waters may endure longer for a time. But in other regions, where life had become used to more stable conditions, the pressure becomes far heavier. The change is not distributed equally among all life. It selects by body, by habitat, by tolerance for heat, by oxygen, demand by depth, and by whether a creature swims freely or clings tightly to the sea floor. A marine ecosystem is not merely a list of species living together. It is like a delicate network where small creatures filter food from the water. Larger creatures feed on them. Organic remains fall to the bottom and nourish organisms in the mud, while species that build structure on the seafloor create shelter for countless smaller forms of life. When one group disappears, many strands in that network begin to loosen. When many groups decline together, the entire web slowly loses its old shape. You can imagine the ocean as a tapestry woven from thousands of threads. Each thread is a species, a role, a way of life, a method of feeding a quiet connection within the environment. At first, only a few threads break, and the tapestry still holds its shape. But then other threads continue to come loose in many places, in many water layers, across many different communities, until the rich image of the past is no longer intact. That is what happened to the ocean at the end of the Permian period. Not every creature disappeared in the same way, and not every sea weakened at the same moment. But when we look at the full picture, the scale of loss among marine life was immense. Many groups that had once dominated the Paleozoic seas declined severely or vanished altogether. Trilobites, those ancient inhabitants that had survived countless earlier disturbances, finally did not pass beyond this boundary. Let us pause for a moment with that image. A trilobite crawls slowly across the sea floor, carrying upon itself a segmented body, ancient eyes, and a hard shell that had endured through hundreds of millions of years of history. It is not the largest creature, nor the most terrifying predator, but it is a symbol of the ancient ocean. It had existed long before Pangaea was fully formed, had lived through many changing ages of Earth. And yet in the end, when the ocean slowly lost its breath, even that enduring lineage no longer had a place to continue. The disappearance of trilobites was not only the loss of one group of organisms, it was like a very ancient sound in Earth's music suddenly falling silent. Even so, the ocean did not become silent all at once. Some species remained. Some small creatures still clung to the edge of endurance. A few groups could survive under harsher conditions, through oxygen-poor waters, through higher temperatures, through prolonged changes that many other species could not withstand. Life does not let go easily, and that is what makes this story both sorrowful and wondrous. Because the Permian Ocean was not only a place where many creatures vanished, it was also a place where life was tested to the very edge of its biological limits. The survivors were not necessarily the largest, the strongest, or the ones that had once been most dominant. Sometimes they were smaller, simpler, more tolerant organisms, or creatures that happened to live in a less severe place at exactly the right moment. In one shallow sea, some shells still lie scattered across the bottom. In another region, the water has become so oxygen-poor that almost no sign of complex seafloor life remains. Farther out in the open sea, layers of water shift in ways that we today can only reconstruct through stone fossils and chemical signals. What the storyteller sees is image, while what the scientist reads is evidence. Between those two things, we try to hear again the weakening breath of an ocean long gone. Perhaps at some point you may ask yourself, how could an ocean so vast be affected so deeply? The answer lies in this profound connection between atmosphere, climate, and seawater. When gases in the sky change, temperature changes. When temperature changes, the ocean changes as well. And when the ocean changes, the creatures living within it cannot remain untouched. They have no choice to leave the planet. They can only search for other waters, change within the limits their bodies allow, or gradually withdraw from the stage of life. The ocean, vast though it is, also has its limits. It can absorb heat, but not without end. It can dissolve gases, but that ability changes with temperature. It can nourish countless forms of life, but only as long as the basic conditions remain suitable. When those conditions drift too far away, life in the sea begins to face pressure from many directions at once. It may be oxygen deficiency. It may be excessive heat. It may be a change in the chemistry of the water. It may be a weakened food chain. And it may be all of these things unfolding together in different rhythms in different places, making the Permian Ocean gradually become far more difficult to live in than before. That is why we should not imagine the ocean being erased in a single night. The reality is deeper and far more haunting. One sea changes first. One group of organisms weakens. One seafloor environment becomes oxygen poor. One sediment layer records the absence of once familiar forms of life. Then somewhere else, the same kind of change happens in its own way. Part by part, the ocean loses its richness. Part by part, the web of life grows thinner. Part by part, the Paleozoic sea recedes into the past. Imagine you are swimming upward toward the surface at sunset. The last light of the day falls into the sea as muted golden streaks, while below you the seafloor fades into warm water. The creatures that remain move more slowly, more sparsely, more quietly. Above, the waves still beat steadily against the shores of Pangaea, and if you listened only to the sound of the waves, you might think the ocean was still as peaceful as it had been for millions of years. But peace does not always mean safety. Sometimes silence is the sign of what has gone missing. There is not as much movement as before. There are not as many layers of life crowding the sea floor. There are not as many shells opening in the current. There are not as many crinoid arms trembling like flowers beneath the sea. There are not as many traces of a world that was once so rich. At the end of this chapter, let us remain here a little longer, listening to the sound beneath the water. That sound is very low, very distant, almost non-existent. It is not the cry of a single creature, but something like the thin breath of an entire ecosystem being pushed to its limit. And when we look back, we understand why the ocean is the most painful part of the story of the Permian extinction. On land, creatures can search for another place, though not always successfully. But beneath the sea, when the water around a body loses oxygen, when the seafloor becomes poor in life, when temperature and chemistry change, many creatures are trapped inside their own home. A home that was once immense. A home that once nourished countless forms of life. A home that gradually became harder to breathe in through time. That is the silent tragedy of the Permian Ocean. It was not a tsunami sweeping everything away, nor a single storm destroying all things, but a deep, slow, and total transformation, where the seawater still looked blue beneath the sun, while inside it, the conditions that supported life were gradually leaving their familiar state. When night falls on the ancient shoreline, waves continue to strike the rocks. On the surface, starlight trembles gently with every ripple. Somewhere very far away, the Siberian traps are still quietly sending gases into the sky. Across the supercontinent, dry lands are still waiting for rain. And beneath the sea, where light no longer reaches, many waters are becoming quieter, darker, and poorer in oxygen. The ocean is slowly losing its breath, and as that breath weakens, the history of life on Earth enters one of its lowest, most somber passages. In the next chapter, we will leave this heavy water and return to Pangaea, where on land, ancient creatures are also facing a world that is becoming increasingly harsh. But before we go look once more at the Permian Sea, at the shells lying still on the seafloor, at the warm and darkened waters, at the deep silence of an ocean that was once overflowing with life. Because sometimes to understand a great catastrophe, we do not need to hear an explosion. We only need to listen to a world breathing more slowly. After leaving the Permian Ocean, where the waters grew warmer and the sea's breath became thinner, through each passing age we return to the vast surface of Pangaea. Here, catastrophe does not take the shape of dark water. It does not wrap itself around the body like the ocean. It does not trap living creatures on the seafloor inside a home that is slowly becoming poor in oxygen. On land, the trial appears through heat dust, distance, thirst, thinning forests, unreliable streams, and the silent tension held in every footstep of ancient life. Imagine yourself standing on a wide plain of Pangaea at the end of a long day. The sky is pale and slightly hazy, as though the light has had to pass through a thin veil before touching the ground. The wind moves slowly, hot and dry. It slips past ancient trunks across low vegetation, through cracks in the earth, then lifts a faint red dust that drifts sideways over the land. Far away, a dry river bends across the plain like an old scar. Where water once flowed, there is now only hardened mud pebbles and footprints softened by time. A group of dicynodonts is moving slowly across the dry ground. Their bodies are low and sturdy, their heads lowered close to the earth, their hard beaks searching for whatever plant matter can still be eaten. They are not beautiful creatures in a modern sense. They are rough, heavy, ancient, like pieces of earth that have learned to move. But in this harsh world, that very sturdiness was once an advantage. One stops beside a low cluster of plants and bites into a stem that is still green. Another uses its forelimbs to scrape lightly at the dry soil, as though searching for roots or plant matter hidden beneath the surface. A young one walks close beside its mother, sometimes stopping in the brief shade of an ancient trunk. There are no loud cries, there is no panic, there is only the slow, patient, weary rhythm of survival. In more ordinary times, a herd like this could have relied on seasonal water sources, familiar feeding grounds, and paths that had been repeated through many generations. But as the climate grew hotter and drier in many regions, the old routes were no longer as trustworthy as before. A waterhole could vanish sooner. A patch of vegetation might not recover after the dry season. A stream might become nothing more than a cracked line of mud beneath the sun. For humans, a map helps us know where water can be found. For Permian creatures, that map lay in the scent of the wind, in instinctive memory, in traces left by earlier seasons, and in the way the whole herd moved together in one direction. But when the world changes, the old map begins to fail. A herd might travel to a place where water once existed only to find dry mud. Another group might discover a water source, but there would already be many other species crowded around it. As resources became scarcer, encounters that were once ordinary grew more tense. A small waterhole could become the center of an entire stretch of land. Footprints pressed over footprints. The smells of many bodies mingled in the hot air. Plant-eating creatures stood closer together, more alert, weaker after a long journey. And wherever tired animals gather, predators are never far away. From a distance, a Permian predator moves through the low light. It may belong to a group of carnivorous therapsids, or perhaps it is a larger hunter with a powerful skull and long canine teeth. It does not rush forward at once. It only watches. Its body is low, its steps heavy, its head slightly lowered, as though reading scent from the ground. In a stable world, predators also have to follow the balance of nature. But when prey becomes weaker, when herds must travel farther, when the young and the old can no longer keep up, opportunity changes as well. Even so, the life of a predator is not as easy as we might imagine. A carnivore needs energy. It needs water. It needs enough prey to sustain its body. If the whole ecosystem weakens, the predator is pulled downward with it. A failed hunt during a harsh dry season can drain its strength. A vast land with too little prey may force it to travel farther. Even a small wound becomes more dangerous when food and water are no longer easy to find. In an ecological crisis, there is almost no absolute winner, because even the creatures that seem strongest are only trying to endure a little longer, adapt a little better, or happen to be in a place that is less severe at exactly the moment when much of the world around them is beginning to become harder to live in. You continue walking through a sparse forest on Pangaea, where dry leaves break softly beneath your feet, and ancient trunks stand farther apart than before, allowing sunlight to fall more easily onto the ground and dry the soil beneath after each hot day. A few trees are still green, but their canopies are no longer dense. The shade is no longer broad enough, and in some places fallen trunks lie tilted with cracked bark, their roots exposed above the earth like traces of a forest not destroyed in a single afternoon, but slowly losing its ability to recover through many harsh seasons. Plants have always formed the foundation of much of life on land, so when vegetation weakens, plant-eating animals begin to suffer pressure, and when the herbivores decline, predators are drawn into the same circle of difficulty. When plant cover thins, soil becomes easier to erode. When soil is carried away, young plants have a harder time growing. And when young plants cannot replace the old trunks that have fallen, the whole land gradually becomes more open, like a chain of links slowly pulled taut through one dry season after another. In one place, rain may come too late, while in another, it may arrive too violently, rushing across hard-baked ground, without sinking deeply enough to nourish the roots below. A forest region may burn under hotter and drier conditions, then take a very long time to grow green again, while the decline of a familiar plant species may gradually pull down the animals that depended on it. Not every place needs to become a desert for life to be in danger, because it is enough for familiar habitats to become fragmented thinner and more unpredictable for land creatures to enter a long, silent, exhausting test. At the edge of the forest, a small creature runs across the dry leaves, leaving almost no clear trace compared with the larger animals that dominate our imagination, such as Dimetrodon gorgonopsians or Dicynodonts. But in harsh times, small creatures sometimes possess advantages of their own because they require less food, can hide in cracks in the ground, in hollow trunks beneath stones or inside shallow burrows, and may avoid the daytime heat more effectively if they can find shelter tight enough to protect them. Yet, being small does not mean being safe, because if the temperature rises too high, if water becomes too scarce, if food gradually runs low, even small bodies will reach their limits. By day, they may hide to escape the heat, and at night, when the air grows gentler, they may crawl out in search of food. But darkness is also the time of predators, and in a world losing its balance, almost every choice carries a quiet risk. Imagine night, falling over Pangaea with no lights, no human voices, and none of the familiar night bird song of the modern world. Only a star-filled sky stretching above an enormous supercontinent, and beneath it ancient creatures trying to live through one more day. A small animal slips through a crack in the rock. A plant eater rests near a shallow water hole. A predator crosses the low ground with steps lighter than its heavy body might suggest, while the night wind carries the scent of dryness, mud bodies, withered vegetation, and a little warmth still left from the day. In that darkness, Pangaea is not completely silent, but its sounds have become sparser, as though the entire land is saving every movement, every drop of water, and every chance to survive. A faint scratching rises from the soil. A heavy breath blends into the shrubs. A dry branch breaks softly under the foot of a passing creature. And all of these sounds do not tell of a sudden apocalypse, but of a world that is gradually becoming more difficult through each long night. If seen through the eyes of a future scientist, these moments would not be preserved like a clear film, because no one can know exactly how a herd of Dicynodonts moved through that hot day, or how long a predator stood beside a shrinking water hole before continuing the hunt. But rocks and fossils still preserve larger signals showing that land communities at the end of the Permian underwent deep changes as many once common groups began to decline. Some lineages disappeared, complex ecosystems contracted, and the world on land gradually became poorer than before. What is frightening is that this change did not happen in only one small region, because Pangaea was immense, and that vastness itself created a problem for life. The interior was drier. Because the sea lay so far away, favorable habitats could be separated by long distances, and when environmental conditions worsened, moving from one place to another could not always save a species. A region that still held water might be too far away. A migration corridor might become dry and barren, and a group of creatures might become trapped in an area that was gradually losing the ability to sustain them across a landmass stretched to a colossal scale. Survival sometimes became a question of distance, the distance to water, the distance to food, the distance to shade, and the distance between where a species was living and where it might continue to live in a changing world. Not every species had enough time enough strength, enough ability to move, or enough luck to cross those distances. Another morning comes over Pangaea as the sun rises above red ground, and the first light, though still gentle, finds heat already waiting in the air. Creatures that survive the night begin to move. A small herd heads toward a lower region. A young one limps behind, and farther away, a predator watches from the brief shade of a rock. On the ground, footprints overlap one another in a chaotic record of need, thirst, and fear. Perhaps in those days, life did not think about the future in the way humans do, but only continued forward, continued to search for water, to search for food, to avoid heat, to avoid being hunted, to find a place to lay eggs, to find shelter, and to find a way to sleep through one more night. But when too many difficult days joined together into a long period, individual survival could no longer hide the weakening of the whole ecosystem, because one animal might survive a season, a herd might endure a bad year, and a species might persist through many generations. Yet if the environment kept changing, if pressure came from climate, from declining vegetation, from unreliable water sources, and from fractured food chains, then every form of endurance would eventually be tested to its limit. There would be species that could not pass through, not because they were weak in any simple sense, but because they had once been suited to a world that was no longer keeping its old shape. They had once been part of the success of the Permian, had lived well within the familiar conditions of their world. But when that world changed too much, the very traits that once helped them survive might no longer be enough. A large body needed more food. A species dependent on moist environments could be threatened as those wet places shrank. A specialized predator could weaken when its familiar prey disappeared, and a slow-breeding species might fail to recover after many unsuccessful seasons in a row. Nature does not judge, does not choose with mercy or anger, but simply changes the conditions of life, and then the body of each creature must answer with its own endurance, adaptation, and luck. In the story of the Permian Extinction, the land did not suffer in exactly the same way as the ocean, but it too passed through a deeply harsh period when four-limbed animals, synapsid groups, many plant-eating and meat-eating creatures, and communities living around lakes, rivers, forests, and plains, all had to face a world that was becoming increasingly unpredictable. What had once been familiar habitat gradually became a maze of risk, where yesterday's path still held water, but today offered only dry mud, where shade that once sheltered a small herd was no longer cool enough, and where a journey in search of food could become a passage beyond the body's limits. And within that maze, some creatures still clung on, keeping the story from sinking completely into darkness. Even in a world where life was contracting, bodies continued to move because some species could dig burrows, some could tolerate heat better, some could eat a wider range of foods, some lived in places that were less affected, and some were simply fortunate enough to be in the right land where water remained longer and where enough vegetation still existed to carry them through the worst phase. A small animal slips into a shallow burrow when the sun climbs high. A group of plant eaters finds damp mud at the bottom of an old river channel. A predator passes over the stronger prey and follows the trail of a weaker one, and a young creature survives the night because it is sheltered in the shadow of its mother's body. These moments are very small against the scale of a mass extinction, but for each living body, they are the entire world. When evening falls, Pangaea stretches once more beneath pale golden light, and the dry lands do not appear violent like an apocalyptic scene, but are even beautiful in a sorrowful way. The sky is wide, the horizon distant, the shadows of ancient creatures lengthen across the ground, and a few clouds drift silently past without any promise that they will bring rain. While from very far away atmospheric disturbances continue to affect the climate, the ocean remains under pressure, and on land, life still tries to hold on to the final rhythms of an old world. After passing through seas that slowly lost their breath through the sparse forests of Pangaea, through dry riverbeds, and the weary footprints of ancient creatures, we now enter the final part of the journey, where the story no longer speaks only of what had vanished, but begins to listen to what remained after one of the greatest crises in the history of Earth. Imagine you are standing on Pangaea after the great upheaval has passed through its most devastating phase, but do not picture too quickly a brilliant sunrise, a green forest returning at once, or a new world overflowing with life, as though the planet only needed to sleep through one night in order to recover. The reality was much slower, much quieter, and it makes the listener feel much smaller, because after the Permian Extinction, Earth did not immediately step into a glorious rebirth, but passed through a long, harsh, and impoverished interval where life had to begin again from the fragments that remained. The sky was still as wide as before, but the world beneath it had changed. The lands that had once held many footprints now became more sparse. The coastlines, once covered with hard-shelled creatures and complex seafloor life, now held more empty spaces in the memory of stone. The forests that had once given shade to herds of plant-eaters no longer kept their familiar richness. The air may still have been hot, the weather still unstable, and ecosystems that had just passed through crisis could not mend themselves with only a few seasons of rain. If you walked across a plain in the early morning, the first thing you might sense would not be the sound of life returning, but silence. The wind still blew, dust still drifted, the sun still rose above ancient red earth. But the number of creatures appearing within sight was smaller than before. Movements that had once made the Permian world feel denser were now scattered and uneven. A small shadow slipped through a crack in the ground. A low-bodied animal moved across damp mud. A smaller group of plant-eaters gathered where water could still be found. Yet all of them seemed like lonely notes remaining after the great orchestra of an age had just fallen silent. Life was still there, but it was no longer the same as before. In the years after the catastrophe, what mattered most was not which species had once been the strongest, the most beautiful, or the most dominant, but which species could endure a world that had been simplified. The creatures that survived were not always the majestic beings we might imagine. Sometimes they were humbler bodies, more flexible in what they could eat, more tolerant of harsh conditions, more efficient in reproduction, or simply fortunate enough to live in regions less affected when the environment around them changed too quickly. One of the most striking images of the post-Permian world is Lystrosaurus, a plant-eating dicynodont with a sturdy body, strong legs, a low head, and a hard beak, often remembered as one of the most successful survivors after the Permian-Triassic boundary. Imagine a Lystrosaurus walking across dry ground in the afternoon, its body neither splendid nor terrifying, like the fang-bearing hunters of the former age, yet carrying in that slow gait another kind of strength, the strength of endurance. It did not know that it was a symbol of the post-extinction world. It did not know that hundreds of millions of years later, humans would look at its fossils to understand a planet that had just passed through crisis. It only knew to search for food, search for water, avoid the heat, avoid danger, and continue living in a world where so many other species were no longer present. That very simplicity makes the story deeper. In ordinary periods of natural history, life is often rich layered and filled with many different ecological roles. But after a mass extinction, the world can become impoverished in a very strange way, as a small number of surviving species spread through the empty spaces left behind by many vanished lineages. This does not mean that Earth had recovered immediately. Sometimes quite the opposite. It shows that the ecosystem was still weak, still lacking enough complexity, and still being filled by species with the ability to endure rather than by a balanced and diverse web of life. If you went down to the shore in the early period after the catastrophe, that same feeling would appear beneath the water. The ocean was no longer as rich as the Permian Sea before the crisis. Many groups of organisms that had once been common in the Paleozoic had declined severely or disappeared, and seafloor communities needed a very long time to re-establish themselves. In some regions, more tolerant species began to appear in greater numbers. Smaller, simpler, or more opportunistic forms of life could occupy the empty spaces. But an ocean with a few surviving species is not the same as a recovered ocean, just as a land with a few shrubs growing back cannot yet be called a forest. Imagine the seafloor after the catastrophe as a house that has just passed through a great tremor. The walls still stand in some places. The floor has not disappeared, but the furniture has shattered. The rooms are emptier, and the familiar corridors no longer feel the same. Life begins to return through small signs, a shell opening in the current, a creature crawling slowly through the mud, a small group of fish passing through shallow water, a layer of microorganisms spreading across the surface of stone. All of these things are small, yet in the long history of Earth, small things are often where new beginnings quietly take shape. Even so, recovery after the Permian extinction was not a straight road. Earth in the early Triassic was still unstable. The climate may have remained hot and harsh through many intervals. The ocean still needed time to escape oxygen-poor conditions in many regions. Food chains that had been broken could not immediately reconnect as before. The surviving species had to enter a world that was not only emptier, but also more unpredictable, where life had new opportunities while still facing pressures that had not completely disappeared. This is a very important point in the way we tell this story. After the catastrophe, Earth did not immediately become a new paradise, but was more like someone who had just passed through a severe illness. Still weak, still fevered, still breathing slowly, but not yet letting go. With each season that passed, some surviving species gave birth to new generations. Each new generation carried small variations, new possibilities, new ways of living that might be better suited to the world after the crisis. In lands where water remained, plants slowly attempted to recover. In places where the ground was more stable, small communities of organisms began to return. Beneath the sea, some groups began to spread, some new species appeared, and the ecological spaces left behind by vanished ancient inhabitants gradually became places where other lineages could begin to enter. But everything required time, not the time of a single human life, not the time of a civilization, but geological time where 1 million years can feel like only a long breath of the planet. If you stood on the same land after 1,000 years, you might not see much change. After 10,000 years, the landscape might still remain poor. After hundreds of thousands of years, a few new communities may have become more stable, but the richness of the old world would still not have returned. Only after immense spans of time, so long that human imagination struggles to hold them, could life gradually rebuild the layers of complexity that the crisis had taken away. And within that long span of time, history began to turn onto another path. The Permian extinction closed the Paleozoic era, a very long chapter of Earth, with trilobites, abundant brachiopods, ancient forests, synapsid groups dominating the land, and countless ecosystems that would never return intact. After that boundary, the Mesozoic era began to open, not at first with the roar of dinosaurs, as many might imagine, but with a world recovering slowly, where surviving lineages tried to fill the empty spaces left behind. Before dinosaurs became the emblem of prehistoric Earth, the world had to pass through this transitional stage. Reptile groups within the Archosaur lineage gradually gained greater opportunities. Some surviving synapsid lineages continued to exist, although their dominant position was no longer the same as before. Land ecosystems slowly rearranged themselves. New plant eaters, new predators, new ways of moving, new ways of surviving, all were being tested on a stage that had just passed through a profound collapse. From a distance, we might say that the Permian catastrophe opened the way for the world of the Triassic, and later still for the age of dinosaurs. But when we tell this, we need to tell it slowly, because opening the way does not mean that the catastrophe had a purpose, nor does it mean that all the losses become lighter, simply because a new era later appeared. Nature does not write its story with intention. It only leaves consequences, and from those consequences, life finds the next path. In an early Triassic landscape, you might see low-bodied creatures passing through mud after rain, smaller bodies hiding beneath the shade of stones, plant eaters, searching for rare soft vegetation, and new predators beginning to test their roles in an ecosystem still taking shape. There is no crowded abundance like in more stable ages. There is no richness like a modern forest. But there is movement, and that alone is a miracle after what Earth has just endured. A footprint presses into mud. A young leaf opens beneath the light. A small creature slips out of its burrow when the sun grows gentler. A small herd passes through old land in search of a new source of water. These images are not radiant, but they are the language of life after catastrophe. Perhaps what makes the post-Permian story most moving is that life did not recover through one great miracle, but through countless small actions repeated across time. A body surviving the night, a young animal being born, a species finding food in a new environment, a lineage not disappearing, a small community remaining stable long enough for the next generation to continue. These things sound ordinary, but after a mass extinction, the ordinary becomes the foundation of a new world. If we return to the ocean, we can also feel that slow return. Seafloor regions that had once been oxygen poor gradually became more livable in some places. Some shelled organisms began to reclaim space. Ammonoids, though they suffered great losses, still had lineages that continued and later became important in Mesozoic seas. These communities no longer resembled the Paleozoic seas before them, but that very difference shows that history does not move backward. It always continues forward in new forms. Earth does not recover by returning exactly to what it was before. It recovers by becoming another world. This is a beautiful idea to hold as we near the end of the chapter. After great losses, life does not recreate a copy of the past. The species that vanished do not return. The old ecosystems are not rebuilt exactly as they were. But from the surviving lineages, from the empty spaces, from endurance and transformation, a new order slowly begins to form. It does not erase the tragedy, but it reveals a deep ability within life, the ability to continue when the familiar world is gone. Imagine a sunset on Earth at the beginning of the Triassic. The sun sinks low along the horizon. The sky no longer carries the color of an intact Permian world, but neither is it entirely the color of despair. Wind moves across a still sparse land, lifting dust and letting it fall again. Far away, a survivor walks slowly toward a place where water can be found. Along the shore, waves still strike stone as they have done through every age. Beneath the mud, beneath the ground, in the water, in shallow burrows, in small bodies, life is still quietly doing its oldest work existing. No one is there to call that moment the beginning of the Mesozoic era. No one knows that dinosaurs will one day rise. No one knows that much farther ahead. Mammals will pass through the long nights of history, that birds will fly through the sky, that flowers will bloom across the land, that humans will one day dig into layers of stone and try to hear this story again. But all of those things in a very distant way began from the fragments of life that remained after the Permian catastrophe. We looking back from the present can find in this story a very deep reminder. Life on Earth is not something guaranteed. It is not protected from every disturbance. It has been tested many times by climate volcanoes, oceans, meteorites, ice ages, and changes lasting through geological time. But life is also not fragile in the simple sense of disappearing because of one dark night. It is fragile in each individual, each species, each ecosystem, yet enduring in the long current of the whole planet. A creature may be lost. A species may vanish. An ecological world may close. But if a few lineages remain, if there is still an environment enough for living bodies to exchange with water, air, light, and food, then the story has not yet ended. The Permian extinction, then, is not only a story of collapse, but also a story of the boundary between loss and beginning again. It shows us that a planet can be pushed to its limits, that oceans can slowly lose their breath, that land can become so harsh that countless creatures can no longer continue yet. After everything within the narrow remaining spaces of possibility, a new world can still be built very slowly. When the final night of our journey falls, imagine yourself standing on a high place, looking out over Pangaea as it enters a new era. Below are unstable rivers, empty stretches of land, surviving creatures moving between darkness and starlight, while in the distance, the ocean is still slowly learning how to breathe again after the long upheaval. There is no triumphal sound. There is no grand music. There is only the wind, sparse footsteps, waves very far away, and the feeling that Earth, though it had lost so much, had still not let go of life. From the small creatures that survived, from the rare young leaves, from lonely footprints in mud, from seas gradually returning to movement. The history of life continued to write another chapter. That chapter would lead to the Triassic, then to the rise of dinosaurs, then through many other upheavals, until much later we are here in a quiet night looking back at the Permian extinction and listening to the whisper of an Earth that had once nearly lost everything, but still found a way to continue. And here our journey tonight through the Permian extinction slowly comes to an end. From an ancient Earth, before the age of dinosaurs, we have crossed the vast dry lands of Pangaea, listened to the first signs of instability in the climate, and the ocean stood before the enormous lava flows of the Siberian traps, and then quietly watched as the sea slowly lost its breath. We have seen that life did not vanish in a single moment, but was tested through layer after layer of planetary change, through each hotter season, each oxygen-poor stretch of water, and each ecosystem gradually becoming more fragile. But after everything, this story is not only a story of catastrophe, it is also a story of endurance. Because even after the greatest crisis ever recorded in the history of life, Earth did not fall completely silent. From the small creatures that survived, a new world began to take shape slowly, quietly, across millions of years. If you enjoy stories of natural history, ancient creatures, the mysteries of Earth, and slow journeys told before sleep, please subscribe to the channel and follow the fan page so you do not miss the next journeys. And before you leave, I would truly love to know, what story would you like to hear next? The age when dinosaurs rose after the Permian, the frozen world of the Ice Age, or a cosmic catastrophe that once changed the history of Earth?